Hi guys. So normally what we do in class is I let you ask any questions that you have. So since this is a recording, basically I'm going to say, make sure you email me if you have any questions, especially if it's questions on homework 2 that are due tomorrow. I will try to answer as much as I can. Yeah, that's pretty much what I have. I'll make a separate video of going over the quadratic equations worksheet that we gave out on Friday that I will show you where it is in Canvas. So the plan of today is we're going to talk inequalities and basically the standards of how we like to write them, including the answers, and then solving some of them, and then interval notation. So that's a shorthand of writing what you can do on a number line, and then maybe absolute value. We're going to see how long this video becomes. Otherwise, we're going to do those Friday. It really doesn't add that much to what we're going to be doing. And then general information. We do still have a quiz on Friday. The quiz on Friday is short. I'll probably give you about 15 minutes again on it. It shouldn't take more than that. It is only on homework 2, which is solving quadratic and radical equations. I think there's like 3 questions on it. It's not too bad. You can use your solving quadratic equations overview notes, but not calculators. The numbers are not bad with it. I want to see how you're doing with things. So yeah. So first things first, I do want to look at our Canvas class. So in modules, the sheets that I'm referring to in our notes are in week 2. The first one is the solving quadratic equations overview notes. You can take this or write it down. This is what I'm going to let you use on your quiz on Friday. When you're solving a quadratic equation, yes, you can use a quadratic formula. However, I prefer you don't. So on the quiz, you're going to be solving a couple of quadratic equations. If you use a quadratic formula for both of them, I will not give you any bonus points. If you use one of the other ways of doing solving the quadratic equations, I will give you a possible bonus point on the quiz. So just saying, I do want you to get away from using just the quadratic formula, because factoring is an important skill that we do have to have for future classes, and completing the square is actually a pretty good skill to have because it helps you with that factoring stuff. So in any case, a lot of people I know on your graphing calculators have the quadratic formula programmed in. However, that doesn't tell me that you can solve it yourself. So that's the rules for that. Looking back at the modules, the other sheet that I'm referring to is we did radical equations. This was notes Friday, and I did post up, and it's, my worked out notes as best I could with my pen on the computer at school with the notes. I gave you those to practice. I have not put the answer key up, but I will. The next thing that we had is the activity that we did. I did give it to you guys to work in groups for a little bit on Friday. I will make a separate video working through all of these so that you can see how I would solve them. Remember, there were more boxes than answers, so some extra answers in there, because the solving the quadratics is what's going to be on your quiz. So the other thing with what we're looking at is today's, I will put under class handouts and practice, I'll put this video along with my notes that we're going to be writing, these notes. And I do have the interval notation notes, a little document up there that we're going to have to add a little bit to it, so you can put it into your notebook, or you can copy down and make sure that it's in your notebook. Cool. So the first thing that we're going to talk about is inequalities, and inequalities are anything that's going to use those less thans, greater thans, greater than equals to's, less than or equal to's. Now, one thing that we do like to have that books don't always like emphasize it. We always like to go smallest to largest. Largest. We prefer to use less thans, less than or equal to's over instead of greater thans, greater than or equal to, okay. There is the smallest to largest takes precedence over the less thans or greater thans. So occasionally we will have to use the greater thans. In that case, we like the variable to be before other stuff. So variable on left is the other ideal thing, but we're kind of used to that. So one thing that I noticed in the homework, and this, if you're lucky enough that this is the problem that WebAssign gives you, we're going to actually solve it. So the problem that I noticed on when I was looking at the homework was 1/2 is greater than or equal to 2x minus 3 over 12 is greater than 1/3. So this actually graded me on quite a lot of things that I was like, seriously, the book does this? So 1/2 is actually bigger than 1/3. That means I had something and I broke it into 2 pieces. 2 pieces, the pieces are bigger than if I break it into 3 pieces. So it's automatically not going smallest to largest. So that's the first problem that I have with it. And then the other thing is we're using greater thans. So what I would do with this is better form. And this is really just as you practice with it, you just get used to it's usually written this. Now, if I'm going to change the order, I have to pay attention to how those inequalities are going. The 1/3 is close to the pointy part of the inequality. This is how my brain works. So I'm actually switching that around because I still need that pointy part by the 1/3. And then I'm going to put this over 12, and then I'm going to do the same thing with the 1/2. Now, this is the better form on the fact that I now have it small to large. I have less thans, which is preferred. However, it's really the smallest to largest that is the bigger problem. So then if I'm going to solve this, we're going to use this color, solve. This is really overlapping itself. That middle stuff, the 2x minus 3 over 12, is repeated. So I can break into 2 equations or 2 inequalities. Rewrite, separating the overlap. First of all, I should put this way over somewhere else. So I'm going to move this over. All right. So when I'm rewriting this, that just means I'm going to have the 1/3 is less than 2x minus 3 over 12. And I'm also going to have 2x minus 3 over 12 is less than or equal to 1/2. Now, I could have done it from the original problem. However, it just was one of those things that I've been doing math for so long that that's very irritating. So it will work a lot smoother if you can always keep from smallest to largest. And that will help you also when you're thinking the absolute values. All right, so the next step that I would do, I'll do this color, get x alone for the variable. So that's basically going to be all of my simplifying. Same rules apply as equations. Methods. The only caveat that you have to worry about if multiply or divide by negative, flip the inequality. That doesn't happen tons of times, usually because I always move the variables to wherever there's more if I can. But you do have to remember that if you do multiply or divide both sides, so you're balancing it out by a negative, then you do have to flip the inequality, meaning I'm getting that negative number that was either multiplied or divided over to the other side. So now, when we have fractions, you have options yet again. This, I'm doing each problem separately, so I can think of this as the proportion if I really wanted to. Not the best plan because then I have to think of where that inequality is going to go. I could get a common denominator, or I can just think, how would I get rid of all of the different pieces with this? Because this is just one whole fraction. So I am thinking that this is 2x minus 3 divided by, because that's what a fraction means, 12. So if I want to get rid of the divided by 12, I'm going to multiply by 12 on this side and multiply by 12 on this side. This 12 cancels with this. You have 2x minus 3 is the less than symbol. And then this is like 12 over 1. 3 goes into 12. 3 goes into 3 once. 3 goes into 12 4 times. Multiply across. This is 4 times 1 over 1 times 1. So this is just 4. Now I still haven't gotten x alone on this one. So I'm going to do the next thing, which is get rid of this plus 3, the minus 3, by adding 3 to both sides. And then I have 7 is less than 2x. Divide both sides by 2. And I have x. And then 7 over 2. 7/2 or 3.5, but really 7/2 work pretty good. They are going to have you, oh, cool. They're going to have you graph your line. We're going to talk about that in a second. This is also, we could write it like this, 3.5 is less than x. All right, so looking at, that's only half of the problem. I still have to solve this other inequality. For this one, I could get the common denominator, but yet again, I'm thinking that this is 2x minus 3 divided by 12. So I'm going to multiply both sides by 12. I can make this 12 over 1. These 12s cancel out. You have the 2x minus 3 less than or equal to. 2 goes into 2 once. 2 goes into 12 6. So it's less than or equal to 6. Add 3. And we have 2x is less than or equal to 9. Divide by 2. X is less than or equal to 9/2, which is, if I put it in my little orange, this is x is less than or equal to 4.5. All right, if I was putting this on a number line, I'm going to draw a line. I'll make it, let's call it. Okay, so if I was drawing on a number line, I need to have these two numbers. These numbers are in order. The x still overlaps, so I really could call this 3 point, whoa, wrong button. Sorry about that. I like that color though, but I will use this. All right, 3.5 is less than x is less than or equal to 4.5 in this case. Now, I do need those numbers, so 3.5 is the smaller number. 4.5 is the bigger number. Remember, if there's negatives, we have bigger issues. I know the x is the less than without the or equal to is an open circle. So I'm going to start by putting an open circle at this number. The less than or equal to is going to be a closed circle, and that's by that 4.5. And so that looks like that. And then I look at it one part at a time. So 3.5 is less than x. So x is at the bigger part, meaning it has to be bigger than 3.5. So it's going to go this way. This is x is less than or equal to 4.5. So it's by the smaller point. So it's got to be smaller than 4.5. And this is where my answer is this shading part, because it's got to be the overlap. It's got to work for both of those when I broke it down. It's an and type of problem. So then we're going to talk interval notation. So this is written out on the number line and kind of set notation-ish. If I wanted it to really be set notation, I would need to have something that looks like this. Let's erase this. And it's not critical that you know this. So I have the variable x, and this is read such that this would be in set notation. Basically, we're used to just the inequality part of it. Totally fine. We are going to talk about interval notation with this as promised in my notes. So interval notation, I do recommend looking at the sheet that I have printed up in our week 3. It is missing some stuff. I need to make it a little bit bigger so that you can read it. So interval notation is basically a way to write the formal definition, a continuous set of real numbers by the numbers that bound them. So basically we're going to have endpoints. We're going to talk about the shading. And if you wanted to look at the actual where I got it from, that was from Brilliant. What it really means is interval notation is a shorthand. It's a short way of writing what information we can get from the number line without having to write the inequalities or anything else. It's really a shorthand. So what you really need to know is some of the basics of it. And it goes the same way with inequalities that we want. We always like smallest to largest. And then we have some symbols that we use to make it into a code. So it's always going to tell us the starting point and the ending point of a shaded part on a number line. So if I have an open circle on a number line, I'm going to use the rounded parentheses. So just so that you know, we can mix and match things as well. So if I see a rounded parentheses, it's going to be an open circle on a number line. Closed circles are square brackets, just plain old square. If there's a gap in your equation, which I don't have in the pictures, but if there's a gap, like the arrows are going in opposite directions and there's this open spot, that will get this U symbol, which means union. If I'm talking about, I just want the overlap part, the middle part that I have, that would be this symbol, which means it's the upside down U, which means and. We don't use that too much unless we're translating a whole bunch of stuff, like an actual problem. So don't worry too much about this. Negative infinity is the same as the arrow shaded to the left. Infinity is the arrow shaded to the right. So I did give you a picture of some of this stuff, but it's missing all of its shading. So we are going to add some highlighting to this because we can. All right. So what I'm going to do is, what color do I want? I want this color. Yeah, green. All right. So this is just the math ways of what they're saying. They're saying finite, meaning it's got endpoints. It's not going off forever. Closed means the circles are closed, and then you, like I said, you can have open circles, and that's what that means. So the closed and open means the type of circles you have. Finite means that it's endpoints. Infinite means it's going off in a direction, at least one of the directions. All right. So for this one, it's telling me the X is between A and B. So what is missing is the shading between these 2 points. All right, and this one, X is still between A and B, so it is still missing just the shading between those points. So you do have to add that into your notes. It can be just a rough sketch. Now this one is showing that we can mix and match. So it's got the square brackets and the rounded brackets. Yet again, my X is between them, so my shading would be right in between them. Okay, and the same with this. This time it's the open circle first and then the closed circle. So we have the shading here. And then when we have infinities, infinity is a concept. It's not an exact number. So they always get the rounded brackets. What this is just going to mean is that my answer is going all the way here and it just keeps going. So I can put an arrow on it if I want, but it's just going to keep going. So if I've got, all right, so it's really telling the same thing. This would be the same thing as a lot of times we don't write this minus and fit from this negative infinity part. So this we're not used to really seeing, but this is really what it's saying. You would see x is less than or equal to b. It would look like this. This is really what we're thinking because we need this for our interval notation. Always has to have a starting point. So that's where that part's coming from. And same thing with here. We don't usually write that. We just say a is less than or equal to, or some number is less than or equal to x. And then we're going to be shading everything bigger than that number. But for interval notation, we have to stay where we started, and we started at a, and we kept going till infinity. So that's just a little added stuff that you kind of useful to know. So it goes on like that. Now this one, yet again, it could be the open circles. They're going to look very similar. We just have the open circle going from there, and I really shouldn't have it shaded to the circle. It should be right before the circle. That's a little bit better, but not much. All right, and then this one does the same thing. I'm going to cheat and do it this. Oh, that made it worse. All right, so try to. Now I can. Sure. Now it doesn't move to it. Got it. And then the very last one is it's just everything is included. And that would be a very kind of creative line where you just basically shade absolutely everything. The answer for that would be all real numbers. Everything is possible. So just for completeness to circle, we don't usually write this. And we don't usually write this. We're not, that's kind of one of those math things. Now, there is a link to a good YouTube video that does walk you through how interval notation works. I think it's about 8 minutes. So that is on the link of the page. So that's just what you needed to add for interval notation. We are going to go back to our problem here, and we're going to translate this to interval notation. So interval notation, we need a starting point, and we're starting at 3.5. At 3.5, we have an open circle, so it's a rounded bracket, a rounded parenthesis. We're always going to put a comma in between because that's telling us we're going someplace. Don't get it confused with a point. And then we're going until we get to 4.5. And that is going to have the square bracket. So that is what they're going to be looking for with some of your answers. All right. So the absolute value, I really think I'm gonna give you just a wee bit of stuff with it. And then we're gonna look at problems like this on Friday. This is distance from 0. So what I really have is if I have absolute value of something, and it could have more stuff like that, I'm gonna say equals this, whatever this number is going to be spaces from 0. Okay, and then when we get changing from the spaces from 0 to actually solving it, this would be what I do is I take the negative of the number. So this is now a location equals whatever was inside the absolute value. And then whatever was inside the absolute value equals the number. So this is now a location. And this is a location. If I'm thinking on the number line. So when we're working on with those things, We are going to always think the negative and the positive and go from there. But we're going to do some of that on Friday if we don't have tons and tons of questions. I am going to stop this pretty soon here because I do want to make the second video where we're going to go through these problems. So remember, I just summarized the solving quadratic equations, the general sheet that we have here. So remembering that I can complete the square. Completing the square is going to have an x equal x plus some number squared equals the number, which is what we had here. Worked out example with that. If I want to factor or use the quadratic formula, I need to have one side equal to 0. When I'm looking here, it's got everything over here and it equals 0. This one, it doesn't have it set up, but you do need it to have all of that. It does have it set up right here. Ax squared plus bx plus c equals 0. The one thing that I would add with this is the quadratic formula always equals x because that's the variable that we need. It just somehow got cut off. I'm going to go with it got cut off. It just got forgotten to be written. With the completing the square, remember we can have all of the x's on one side and the numbers on the other side, and we work from there and finding that number we have. So that's from a couple weeks ago. That is actually something that I do kind of want you to be able to do. Normally, if I say solve an equation, I'm not going to tell you how to solve it. But I do encourage you to do completing the square. I'm gonna expect to see it. If I'm not seeing it, then I will give you a quiz on just showing me that you can do a completing the square. Cool. So like I said, look for the second video. I will be putting both videos in the class handout practice. I will probably email this video out first. And I will put it into my YouTube channel, which has got most of my developmental stuff, not so much college algebra stuff, but I'm working on building it. So, all right, come to class Friday with questions and be prepared for the quiz with the notes that you are allowed. You can have anything that's on this page can be in the notes that you can use on your quiz. All right, we'll see you Friday.